Okay, let's get started. So, first things first, what is a fraction? So a fraction is a form of writing a number written like this, where we have a numerator, so n for numerator, then we have let's just write a d for denominator. So we have one number on top and a number on the bottom divided by this line here. Now an example of this is 1 over 2, 1/2. That's a fraction. And what this means is, let's say we're talking about pies, that would signify half of the pie, because you're taking one pie and dividing it into two pieces. So 1/2 of the pie would be all of this that's shaded. All right, another example. What if we had 1 over 4? Is that a fraction? Yes, it is a fraction. And here, it would be the orange part. That is 1/4, because I'm dividing the entire pie into 4 pieces, and I'm taking 1 out of the 4 pieces. All right, let's start evaluating them. So, if I have 1 over 5 of a pizza, how much is left? So let's first draw our pizza. So we have our circular disc. This pizza, how many slices will there be? There will have to be 5 slices. 1, 2, 3, 4. That's not right. Okay, let me try it again. 1, 2, 3, 4, 5. All right, not very equivalent, but you get the point. We have 1 slice, 2 slices, 3 slices, 4 slices, 5 slices. If I have 1 out of the 5 slices, that means I'm getting 1 of these slices out. So let's say I'm taking the second one here. That's 1 out of 5, right? Okay. What about, actually, let's answer the question. How much is left? We have 1, 2, 3, 4 out of the 5 slices. So we have 4 out of 5 left. All right, now what if instead of drawing it, we just evaluate it simply with the numbers that are given? For example, if I eat 3 out of 6 slices of pizza, how much is left? Since I took 3 out of the 6, I do 6 minus 3, and then I'm left with 3. So I'm left with 3 over 6 is left. Okay, now what if, okay, so here we know that there's 3 out of 6 left, right? After I eat 3 slices. Then, Zach eats 2 slices. How much remains? So at first there was 6 out of 6, right? The pizza was full. Then I came along, Sal, I ate 3 slices. Then Zach came along and he ate 2 slices. What's 3 minus 2? We have 1 left, meaning that how many remain? There's 1 slice left. All right, cool. Now, what about something called simplification? This process is where we find fractions like 3 over 6, and we show that they are equal to 1 over 2. And the reason for this is because when you divide the numerator and the denominator by the same number, you can reach this number. So if I divide by 3 and I divide by 3, I'll get 1 over 2. Now, if I take 3 and I divide it by 6 and I want a decimal, I'll get 0.5. What if I do that to 1 over 2? I'll also get 0.5, and that is because they are equivalent. Now, what about visually? Are they the same visually? Do they look the same? Let's try that out. Here we have a pie, and here it's split into 2. Okay, now since it's split into 2, and I have 1 out of the 2, it's going to cover 1/2 of the 2, right? This is representative of 1/2. Now, what if I was looking for a pie that was representing 3 out of 6? Let's see what that would look like. I would take 1 slice, 2 slice, 3 slice, and I would cover these 3 slices. Those would be the 3 out of the 6 total slices. Do you see how these are the exact same? They're exactly equivalent. So if I have 3 over 6, I can rewrite it as 1 over 2. And if I have 1 over 2, I can rewrite it as 3 over 6. Let's do one more example. What if I had, let's see here, 6 over 12, and 2 over 4, and 1 over 2. Are these all equivalent? Yes, they are. Because if I divide 6 by 12, I get 0.5, and that's equal to what's 2 divided by 4, it's 0.5, 1 divided by 2 is 0.5. And if I drew them to see what they would look visually, I would get the same answer. They would all look the same. So let's say I did this one. 1, 2, I have 4, I have 6, 8, how am I supposed to do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now if I take 6 out of these, I take 1, 2, 3, 4, 5, 6. Okay. Then I take this one and I divide it by 4. So I do 1 and 2. Then I take 2 slices, 1, 2. And then here I'll simply divide it by 2. And I fill it in. Do you see how this one, the first one, this one, the second one, and the third one are exactly the same? 6 over 12, 2 over 4, and 1 over 2. They are equivalent. Although they aren't written the same, they are equal to each other. Okay, now this is going to be a very important concept once we get started with operations, like adding fractions, subtracting fractions, and so on and so forth. For now, I just want to do a couple more examples for the simplification portion, just so that we're ready to move on to more complicated uses for fractions. So, if I have, let's see here, 6 over 32, and I want to simplify that. How do I know that I can simplify it? I look at the top, which is the numerator, and I see if I can divide the numerator and the denominator by the same number. Now, luckily for me, these two are not odd numbers. Since they're not odd numbers, they're pairs, I'm able to divide each one by 2. So what's 6 divided by 2? That's 3. What's 32 divided by 2? That's, what would that be, 16? Now I have 3 over 16. Now can I simplify this? Unfortunately, I cannot, because the divisors of 3 are 3 and 1. Yet 16 can't be divided by 3, and if we divide it by 1, it'll remain 16. So this is our final answer. Okay, now what if we tried another one? What if we had odd numbers? What if we had 7 divided by 21? Now, what are the divisors of 7? We have 7 and we have 1. And 21 has 3 divided by 7. And since we know that they're both divisible by 7, let's do that. Divided by 7, divided by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. So it's equivalent to 1 over 3. All right. Let's do one more. Let's try some larger numbers. Let's do 36 divided by 108. So, what number can we divide 36 by that we can also divide 108 by? There's a couple. What I'm thinking of is 9, and there's also 12. Now, with the larger fractions, we usually use our calculator, so it's all right to use them now. I think I'll go with 12. Since it's a larger number, I'd rather divide more out of it. Okay, let's divide by 12 on the top. We get 3. Over, we have 108 divided by 12. What's 108 divided by 12? It's 9. 3 over 9. Is there anything that we can divide 3 by that we can divide 9 by? I'm thinking of 3. So let's divide 3 by 3 and 9 by 3, and we're left with 1 over 3. All right. So does that mean that 36 over 108, which is equivalent to 1 over 3, is also equivalent to 7 over 21? Yes, it does. They are both equivalent. All right, that's all for today. I hope this was a useful lesson, and I'll go into the operations and addition and subtraction in the next video. But until then, I'll see you in the next one.